So today I want to talk about whether or not we have had uh, any experience deploying um, Arduino or working with Arduino, or similar type technologies, moving uh, from getting started being a maker and then into professional development, and then beyond that, if anybody's tried to actually deploy this stuff into the commercial world, into the wild. I've had a lot of interesting conversations about this over the years on both sides of the fence. Early on when I um, started in the field, Arduino was still becoming a thing. Raspberry Pi had been around for a little while, and there had been some horror stories about uh, companies who have um, tried to take, just plain off the shelf Raspberry Pi or off the shelf Arduino into production and experienced all these problems, such as, the components aren't actually spec'd for commercial deployment, and et cetera, et cetera. So I'm interested to see what everybody thinks about that. Because since then, there have been new flavors of Raspberry Pi and Arduino that have been developed specifically for deployment. When I was at CES actually earlier this year, I was talking to some of the folks over at Bosch, and they were saying that they've started partnering with Arduino on a platform called Arduino Pro. And I'm not sure if any of you guys have heard of Arduino Pro, but what they're doing is deploying a bunch of Bosch sensors, the sensor tech guys, so all their different sensors on these little these little platforms that are modules that are sort of ready to go, ready to deploy. And I think that was a indication for me. It was not a platform that was developed by somebody other than Arduino. It was not a platform that really had any intention of being used in any other way than commercial deployment. And because of that, it's like, well, I mean, we may be at a point here where these Arduinos have officially moved on from being toys, and there's a lot of opportunity for non-Arduino or for Arduino developers to be taken seriously. So I'm not sure what your guys' experience has been with that, but before we get going, do you guys just want to go around the horn and say hello? I think we all here today know each other, but do you want to start, Navdeep?
Oh, yeah. Hi, hello everyone. From Bangalore, India. Currently working in the domain of electronic design, mostly into embedded hardware, software, and little into content creation and stuff like that these days. Yeah.
Cool. Umesh?
Hi, this is Umesh from Pune, India, and I'm into embedded system from past 10 years. So it includes software and hardware all together. Thank you.
Cool. Joseph? You're muted.
Sounds like he's driving.
All right. How about you, Mike?
Oh. Hey, everybody, good to see you. It's a sunny Arizona morning here in Arizona. Happy to say. But, I've got a call starting right at 9, so I'm going to drop off a few minutes early here to prep for that.
Cool. Tricia?
Hello everyone. So I am Tricia from Bangalore, India. So I mainly work in embedded field and also like hardware design part of it. So recently I've been working with IoT modules, design modules, and then IoT devices as well. So yeah, that's about me.
Cool. All right. Well, let's jump right in. One of the things that I brought up was, hey, wow, lots of people start on a platform like Arduino, and then what happens? So I want to get sort of a flavor for everybody here. Where did your developer journey start? What was the first entree into embedded or IoT electronics? What was the platform? And then How did you grow from there? Navadeep, do you want to go first? So you told us last week or the week before that you maybe had a weird path where you started with FPGAs. Is that where the first like target that you were working with?
Oh no. So out of secondary school, probably 6 years ago, I started with Arduino uh, before joining engineering college. So it was like typical Arduino which I ordered over Amazon and hooked over to the laptop and did that LED on, LED off. And stuff. So that's where I started, and it went on to kind of get, being curious and getting different types of sensors available over Amazon, ordering one to the cart, ordering one every month, and trying to interface them. So one of the very interesting tutorials which I was following over YouTube. Um, I'll put the link. I forgot the name of that person. He's from US and he retired and lives in Africa in a small home and spreads his love through Arduino tutorials to the world. So that was fun, and that was my starting point. Then it went on to getting a little deeper in that, and someone saying, "Hey, dude, grow up, use something else." So hopped on to other MCUs, trying to learn assembly and stuff. Yeah.
Cool. So when you began, what was the point at which you said, okay, I'm moving from being, somebody who's just interested to somebody who's going to take this seriously? And what was the path technically there? Did you obviously you said you've been tinkering around with different types of electronics, but there's a clear jump from when you're using the Arduino IDE, for example, working in C++, and then going into whatever's next, like whichever path, So what was the inflection point there where you realize like, okay, like I'm going to do this, and then what was the step that you took?
Yeah, so probably for around 8-10 months I was doing this Arduino, and then I got curious about blogging and stuff like that. So I created a small blog, blogspot page, and tried to put content over there. Then I realized there are a lot of people in the world who can write better than me, and so I saw a lot of tutorials there. Then I kind of wrote a bunch of stuff there, and then got into some internships based on that. So maybe I'll touch about. Interestingly, we were using Arduino in one of the deployments. I'll tell that story later, but yeah, it happened so. And then I thought, okay, of course, browsing over internet and through curiosity, I jumped upon different types of controllers, HM to microchip, PIC, and stuff like that. So I saw which had the lowest entry point, lowest barrier to enter. So PIC was one of them, but I could not get the debuggers and all. They were quite expensive, getting the kit and also the debugger. And the STM32 was one thing, but I think it was right during that. I think where there was chip shortage and the supply was not cool. So I jumped into MSP430 at that time. So I just went to TI.com and ordered one of the MSP430s. They happily shipped over DHL for around $35, I think, one FR5994 kit. So I started with that Brock Lemieux. He's a professor from University of Montana. He had written a book about embedded systems from very, very scratch, just by MOV, add A and B instruction from that level to everywhere till you do timers and counters using assembly. So I stick with him till some point, after which I felt it was tedious to learn assembly, doing all the counters and writing, trying to backtrack the DSA, like the algorithms, doing binary search, fully using assembly and all. Then I moved to real C programming, where trying out proper sensor interface using HAL libraries and stuff like that. So I would say inflection point was generally browsing over forums. I hit upon someone saying, hey, there is some cool thing called MSC430. You can learn assembly over there. Arduino, although Arduino exposes it, but there is a lot of abstraction. So yeah, that's I can't hear you, Brian. Now, probably you're on mute.
Sorry. Have you had any experience trying to take Arduino into production in any capacity?
Yes, one time. This was my first internship. I was in probably first year of college, and roaming around streets of Bangalore trying to find somewhere where I could just get hands on, like work for free for them and just see what's going on in the company. So interestingly, there's some place called NASCOM. It's an initiative by government where it funds or like incubates certain startups. So I got in touch with the company called Gramworks. So they were at very initial phase of their uh, venture, and then the idea was basically to have multi-sensor put over agricultural field, capture the data and provide insights to the farmer, saying, hey, your humidity or your water soil humidity or whatever temperature is like this, and your crop might get infected with these diseases and things like that. The vision was big. We thought of deploying all the algorithms, AI algorithms in the edge within Arduino or ESP itself. So there, it was not it was on Arduino platform, but not the like Uno or these board. The board was called TTGO TCOL. It had ESP32 and a SIMCOM module, and programmed through Arduino IDE. So I initially worked on interfacing a couple of sensors, the SHT31, all those like typical temperature, humidity sensors, moisture sensor, wind speed, wind pressure, gauge, all those wind vane for the direction of wind and all those stuff. So basically, we were trying to cluster all the data, get in a single dashboard, and were initially we were able to spin that first prototype in some 4 months working on these out of the lab. So then went on to deploy the same thing in the field. It did work. We logged everything up in a IP67 case and put it in the field. It happily worked for quite a long time until we realized we have to optimize for the cost and make our own custom design because the module itself, which we were getting from China, was costing around 1,400 rupees. That's I don't know, probably yeah, $20-30. So yeah, that was happening, and we wanted to optimize the cost. So that's why I then went on to do the custom platform, like custom design, and then deploy. So I would say it wasn't a great idea to put the maker developer kit in field, but it did work in our initial phase until we had enough revenue or to scale up and build our own hardware.
Why do you think it wasn't a great idea besides the cost? I mean, it seems like the limiting
Uh,
factor here just became the economics of it.
True. One is of course the design. It is not optimized, with power, or the component may not be rated for field temperature. Although we put in IP67 case, it is irrespective of all the humidity or temperature outside. Temperature might affect, but the humidity is kind of enclosed. But it definitely wasn't optimized for the use case. We had a bunch of other peripherals or a lot of pins exposed, and just a development kit sitting inside box, and some sensors interface through put on a perf board and soldered. So that was quite fragile as well. It's not very resistant to vibrations and even temperature. Yeah.
But for your purposes, it sounds like it actually was effective because you got to the point where it's like, okay, we've got a proof of concept, we've got it deployed. We're at a point where we can cost optimize, right? And, if you're trying to go get funding or whatever, you've got like a real working deployment at this point, and you can go to investors or whatever and say, hey, look, if you give us X dollars, we can drop the cost of this thing down per unit. We can scale it a little bit. So
Yeah.
if is that the case, and where is it now?
Yeah, that's quite exactly what happened. I was with them for around 8 months. Then I moved on, with my college work and stuff like that. Although I stay in touch with them now. After that, what happened is exactly the same thing happened. Like we deployed it in a couple of farms in central India, and then took a testimony, like reviews of the farmers, and then pitched it to the investors. Got a good funding. We scaled up, built custom platform, custom hardware, software, all of those. Deployed in probably scale of 1,500 devices. Then the IP got sold to a company called Wakecool Foods for $1 million. So, and then that's what happened.
So maybe it is a good idea to go into deployment with Arduino.
Yeah. At least in the initial phase, until one understands the whole platform properly, and it's just a initial thing to do. But after all, if you want to optimize it, any sense, if you look at any sense like cost, power, even the if you want to optimize it for environment, stuff like that, you definitely need to go study first, understand, and then customize it. Yeah. I would be happy to know what Umesh says, what Mike says, if mine is
Yeah,
succeeding. I'm
I'm
sure
gonna
they
go
would
to
touch
I'm gonna
upon
go
it.
to Amesh next. Amesh, what's have you done such a thing? I'm assuming you've probably at least thought about it.
Oh yeah, I mean, I have not started my journey with Arduino because it's been long time when I started. I started with STM32 because I was in 2010 I was at the Embedded World Conference, and I was just walking around and I said I'm thinking of doing some hardcore embedded system, and then there was a field application engineer who handed over me just a bunch of like 10 15 kits to me, and that's how I started with STM32 discovery boards. The way I got to know Arduino is I was building some projects in my master's studies, and I was showing quite a few things to people around me in my Wege. Like we were sharing apartment with 4 people, and there were a girl who were studying a design, industrial design, and all other stuff in Weimar University. And she was non-programmer, by the way. She have nothing to do with the programming, but she started building some really cool applications for her designs. And that is where I asked her, like, how have you built all this things? And she said, like, I'm using this Arduino toy. And then I said, okay, what the hell is this? And then I looked at it, and the simple thing which I try to do, and I have to read for 2 or 3 days to understand, she, without any electrical background, she could able to do this by just reading APIs and all. That's how I got to know in 2012 that this Arduino does exist. And I was a little bit jealous because the way I learned was hard, and I saw right now this guys who have nothing to do with electronics could able to do that. But I don't want to stretch the story long. I just keep it short. First I thought maybe this is just a toy for blinking LED, and then rotating servo here and there, that's it. And then even I used to write a blog. I used to talk to people and just criticizing Arduino. This is from 2012 to 15, 2015. I used to criticize all the time. But I think I learned and understood that Arduino has a massive potential right now, not because of the hardware, but it's because of its software ecosystem that it has built on. And if anybody here have done any business with electronics production, they could clearly understand that succeeding with modules, even you create industry grade modules, is not easy thing because you have a volume problem, right? And that is where I see even these big companies are coming up with Arduino compatible. Like 2015-16 there was a trend, and right now you yourself mentioned that Bosch is taking very seriously by incorporating their all the sensors, which is basically an Arduino compatible. And you might have seen, once you create a module which is Arduino compatible, then they are compatible with Nucleo board, and then they are compatible with Renesas, and this just goes on and on. And people solve the problem by having this compatibility across the hardware. So I think that is where the Arduino wins. And as far as the simplicity goes, they have done awesome job towards software. I love what they have done.
So, really quickly, how do you differentiate, Imesh? I know you've used ESP32. How do you differentiate, an ESP32 from an Arduino today? Like, what do you think the difference is?
I would always stress on software, Brandon. I'm not a, I don't have a feeling that there's an hardware you make money. Okay. And even that's why I always tell my people, like, if you're a hardcore electronics engineer, at least in India, people don't pay them. It's big injustice happen. So I would just talk in terms of software. Okay. I feel even today afternoon, I was trying to install ESP32 IDF IDE, right? And I tell you, with this much amount of experience, still there were an issue with compiling the code. Okay, one screenshot I just posted a couple of minutes before. I don't know why this company's ESP32 or STM32 ID is pretty stable, but it's still, at the higher end, very complex applications, still people have the problem with Hell APIs. But when you look at Arduino, it's really a simplicity, just double click, it just install. You write a code, you compile, it works. I'm not saying it does everything what it does, but as far as the software goes of Arduino, I think they really know what architecture is all about. They know how to build the good IDE. The technical limitations are there when you optimize your code at very low end, like a power or something like that, or optimizing for lower footprint of the code binaries. But I think this Arduino wins the game of this IDE and compiler. I mean, I could say that's why I think one more point. That's why even if these are the bigger companies, they don't have they can't able to do anything. So finally what ends up happening is they make their chips compatible with Arduino IDE. That is, I mean, what the hell, you have such a huge, billions of dollars of budgets, and you can't able to just do what this Arduino 6 people sitting in Italy is doing. So I just can't understand. So I would just say, like, they have the fantastic architecture which the maker creator loves, and then maker creator become a professional. That's the trend of in electronics, right?
Yeah. Mike, I want to ask you this, just because of your time in industry, and there was a while ago, maybe 5 years ago, that, like, are you familiar with OnLogic, Mike? Yeah, like OnLogic started using Raspberry Pis, like doing like hardened, like enclosed Raspberry Pi products. Have you had any experience in your space with people, with either yourself or customers, going down that path of deploying these types of solutions, and what was the outcome?
Yeah, it's interesting because I've got mixed feelings about it. The big issue, there's two sides to it. One, first, they're great tools for education, proof of concepts, things like that, being able to get hands-on and get things done really quickly, and that's fantastic. But it lulls some people into the thinking that, okay, now I have or I almost have a product. And this has happened to me many, many times. We worked with a industrial or a commercial kitchen equipment manufacturer, and they were trying to add more controls and have a connected kitchen product. So they had a new engineer. This is probably 8 years or so ago. And he developed, on a Raspberry Pi, basically most of the solution, and demoed most of the solution for the president of the company, and said, look, it's all working at this little thing. It's $25, $35, something like that. And that lulled and this is an electromechanical company, right? They're not an electronics shop. They haven't really dealt with stuff like this before. So now the CEO thinks that he's got the product almost developed. He thinks that it should cost $35, and he starts to talk to some other people in the industry. I think I was with Advantech at the time. And we say, you don't want to put this thing in this induction. Look, you have high temperature ranges. You're going to support this thing in the field. You expect it to have a 10 to 15 year life cycle, things like that. But he had now, instead of moving to like an industrial PC type platform or an industrial single board computer, he had stuck in his mind that $35 is the right price point. Now maybe I'll pay $50, sort of thing. So it set up a dangerous set of expectations around cost, and also the fact that he felt it was almost done. And so when you switch over, if you come to the realization, so, okay, this is great, I've got my proof of concept, maybe I've got my funding, that's all great uses, I think, of those platforms. But then you have to realize that it's going to be, most likely, it's going to be time to start over from scratch and develop this on a commercially viable platform suitable to your environment and your supply chain requirements. Now, if you don't have stringent supply chain requirements and it's just a consumer type device and it's going to be out there for 2 years at a time, you're probably going to get away with it just fine. But if it's a more industrial device, 10, 15 year lifespan, wide temperature ranges, vibration, high support costs, the customer expectations of your brand and things like that, And also just that supply chain. Especially if it's in a critical device, it's in some sort of industrial device, it's safety rated. Now every time somebody revs that Arduino board, you got to go back to UL and spend $25,000 to to get your update to class 1 div 2 and retest and all those sorts of things. So maybe with these companies like Bosch and you've done it over the years, trying to industrialize, I think they're trying to solve that in between problem. As long as they can write a service agreement that says, look, well, here's our support agreement. This thing has a life cycle of it's going to be this long. It's never going to change and things like that. And it's got the right specifications. But then I suspect the price isn't going to be as attractive as the educational version, sort of thing. So I don't know. I think that's why my fear with those is they set the expectation that, hey, we did a quick spin and we got something done, but you just have to realize that's a prototype. And then the downside of that is that prototype doesn't take you towards your, it helped you prove out your business case, but now you need to start your engineering from kind of ground zero. But not everybody at a management layer understands that. Once they see their first demo, they think, oh, good, we're about ready to go to market.
Yeah. Well, and Bosch clearly also has multiple ways to win, right? Okay, well, yeah, we've got this pro version of Arduino and we've got a bunch of our sensors on here, but then people are inevitably going to use this and then we'll sell them, our sensors like Navdeep was saying off when they try to spin their own custom board. One question for you, Mike. I know that this is where this gets difficult because you've been in technical leadership, right? And excuse me. Okay. Maybe I'm okay now. So you point out the fact that it's like these are great for education. This is great for prototyping, and the theme here is that, well, there are all of these young engineers who this is how they learned to do this, right? But as to your point, you then get to this place where it's like, well, better go start from scratch. And it's like, well, all of my developers now don't know how to develop on that platform, this start from scratch platform. So from like a management perspective, how do you contend with that? Advantech, for example, is a triple, quadruple platinum plus Intel partner, right? And that's a whole different ball of wax than Arduino. Like, so what do you do with your workforce?
Yeah, well, I think at some point, I guess that's the risk if you wrap up your whole development knowledge base around an educational tool set. You have to realize that you're going to have a limitation there at some point. You're going to go to work for a company that says, look, we're an ST Micro shop, or we're an Intel shop, or we use nothing but microchip, and you're going to have to get into that whatever environment they choose. And a lot of times in those companies, as I think about a lot of different cycles kind of through my history, in our early years, we did a lot of microchip because this was all before Arduino existed. And then it didn't, once we had all of our engineering team up to speed on microchip, we didn't think about, okay, hey, for this next process, next project, should we shop around to different microcontrollers? No, we have all the microchip tools. All of our engineers are up to speed on it. We just use whatever microchip has that's the best fit for this project. And we became basically a team of, 20 engineers or so at that time that were all microchip people until we got to the point to say, hey, it's time to jump ship to, ST Micro or something like that, because this next generation is just so much better. And now we're going to go learn that environment. So, I think you just tend to grab onto whatever environment it is that meets the business needs to start with. And then you tend to cling on to that for a while just because of that learning curve of jumping ship is kind of steep, until something like, I guess we went through recently where we had to switch from, I think it was just through the supply chain crisis. We on one program in wireless sensing, all of a sudden the microchip stuff wasn't going to be available for 18 months. So all of a sudden we had to do an emergency, report everything over to another, product line and, just suck it up and deal with it just because, because it's the only thing we could get stock of.
So I don't know if everybody's aware, but we've been doing these demos, and we've been focusing on essentially getting started with, embedded and IoT technologies. And then over time, we're going to up level, to more advanced topics. These are like 5-minute long things. And as part of this, I've been looking for x86 developers who appear to all have but disappeared. Like they're it's like impossible to find somebody who, is not locked up in some cell in the bowels of Intel, and who develops on x86. And so my point becomes is, just a continuation of that thread, which is, well, yes, it becomes a management decision where it's like, do we need to diversify, or at least be cognizant and recognize that, what I'm going to get from this region of my team is prototype level stuff, and it's good and that has its place, but we also need to have a team that is able to, that is well-rounded enough to be able to migrate that into something that's deployable. However, people aren't learning on Intel Core processors today, right? People aren't learning, except Navdeep, people aren't learning on Xilinx, Zinc FPGAs, right? So where do you even do? Do you just, it becomes a race to the top, I guess, of paying whatever those developers want at some point? You got the $1 million a year FPGA HDL programmer. Is that what your experience has been? That's Mike.
Yeah, it's a good question. I haven't really, maybe partly because my last gigs was with Advantech, anybody that was doing any work really on the developer side was all in Taiwan or China. But it's essentially what they were deploying was, it was hardware reference designs, and so you're right, all the real brains get locked away within Intel. And I think, the people like Advantech and Supermicro and such are essentially deploying the reference designs of Intel designers. So that's a good question. I don't know the answer. Basically, everybody that's doing Intel designs is part of those partner programs of Intel, right, and kind of wrapped up in there, and they get invited to the, while I was with Advantech, I got invited to a few of those kind of Intel parties of, that are, giving you insight, 5 to 10 years out of what they're doing and where they're going, and trying to get your feedback as they looked at us as an integrator, basically, and
right.
saying, hey, here's what's coming, and what do you think, and which, do you think this one first or this one first? And but yeah, those are kind of private parties, and it's not like it's a whole opposite end of the ecosystem from what Arduino's doing, where they're kind of democratizing down to the high school level, right?
Right. It's really, it's funny you said that, and then I'll course correct, but it really becomes almost like those meetings become almost like a president's club, like a sales president's club, because these are sales channels for Intel, right? Like that's what they are. So yeah, it's interesting to think about it from that perspective. But yeah, I last thing I'll put on this point, which is I hear a lot of times about the engineering shortage, air quotes. And I wonder if this is actually what it is. What we're really talking about is actually the fact that it's not necessarily an engineering shortage per se. It's a shortage of engineers working on these specific platforms that the industry is set up right now to go to market with, right? And what that really means is, well, maybe the industry needs to reconfigure itself to go to market with something else, potentially. But Tricia, you've been doing a lot of head nodding and thumbs upping and smiling. What's your experience been?
Yeah, I think I have a lot of points to say, because I think I was in the generation where like the Arduino gained a lot of its popularity, and even that is also what I was like started with. So my journey started when I was in like the second year of my like pre-university basically. So there I did some bots basically, where I had to program them and use my phone to like use like Bluetooth kind of thing. I did it there. So that was one of the thing. So mainly like when I think about Arduino, it was like at that time. So it was a thing which got me started basically, like in programming basically. Not even like I did like for a PC program, which was basically like for me the thing to microcontroller programming. I got it started with the Arduino. So the movement to a like better platform or this one happened when was like I had to write the register level code in the Arduino itself. So it allows me to write the register level codes. So some timer issue I faced, and I had to like get the exact timing. So at that time, I had to write the like register level code. So then I moved to these other platforms, and you have to understand, like at that time the ST microcontrollers were available, but the controllers, it's the main selling point of the Arduino was like it could be programmed via UART. So every other company had their own proprietary programmers and debuggers, and the selling point of Arduino was like they had put some bootloader in there, and that used like that could do the UART programming basically. That was their big selling point. So even now they have it in all their boards. So that is why like I feel like that popularity gained mainly because there was no like UART module. Basically USB to UART modules are very cheap compared to proprietary programmers. Even ST had their own proprietary programmer, so ST Link. And then like the new wave when it started, like Chinese clone program like debuggers came, then the gained popularity. And before that their HAL was like really badly documented, and like there were like people so much cursing people like on their documentation, like really bad documentation ST had it. And they had multiple platforms as well where the ST could be programmed, and multiple levels like low level, high level, many different kinds. So yeah, so I moved there and then I came back again. The thing is like the engineers nowadays, which I feel like everybody's like, I am an embedded engineer, they say it on top, but when you see it, like they just do the know the Arduino. So that is the bad point, I would say. Yeah, so bad point. That would be a very bad point. So they need to understand the register level and like the embedded C part of the coding as well. So that if they miss on, then it will be really hard. So even nowadays when I'm working, I like Umesh said like he was doing something. He was setting up the IDF actually for the ESP32 development. So I was the similar case. Like I was setting up for one of the project which I was doing. So and I was like, it was a little bit of a time constraint. So I then moved back to Arduino again to program it entire thing to do a POC for it. So again, so back and forth I have been doing this. So another thing is also like most of the hardware which right now is like everybody, it's like a new Python kind of a thing. Everybody develops all the free people, open source people develop the libraries for it. So libraries have become very abundant and very tested as well. So some of the libraries are very optimized, I would say. So like for the application, so for example recently I was searching for IR library. So there are libraries like that's very well written where like they support like 50 kind of IR protocols. I don't know like if it's supported in the ESP environment. So what, even if you can find a library or you will have to write it yourself, that would be even harder thing to do. So this would be the main selling point of the Arduino. It has become a new Python kind of a thing where like people have put so much effort. It's open source. People have put so much effort on it, and like the libraries have been developed for that syntax basically. So huge resource has been built up now. So it has gained a good momentum now, I would say. Mainly like that IR part was a very small part. Similar way, everybody like if you see most of the popular ADCs or those things, everything has a library for it developed in Arduino. I think that comes basically first. If it's a big selling thing, big good feature set, and even the companies have realized now like okay, supporting these kinds of open source movement will get lot of people to work our sensors, our I2C component like peripherals, external peripherals. So people, they are even now the big companies are actively supporting Arduino environment. For example, if you see STM has like, there was a guy, open source guy who started that basically STM core for the Arduino. And like then the ST people like okay, they saw so much potential, I believe. So they actually took over that project, and now they are actively maintaining that STM32 core for the Arduino. So they have like STM engineers who maintain those actual library for these libraries and everything. So right now, like if you see STM32 is directly supported in Arduino, the same situation is with ESP as well. And ESP is the main thing. Like I set up everything, IDF and everything. I got it working and everything, and then I had to integrate the library to that part. It's basically CMake environment, and I'm not that much familiar with CMake. So I actually had to move back to Arduino to set up everything. And again. So I just got it running so quickly in Arduino as well, because there was multiple part of that project where I had to do, and I was like, question mark, should I actually invest this much time? And I don't have the time. And my manager was like, what is it? I just need a POC. Can you get it done quickly? And he was like, fine, I will get it done in Arduino. So that was the one thing. So it is like, you, when the POC is designed, or like if you see some of the boards which are designed on STM, or if you see Texas also supports now, Texas Instrument microcontrollers also are supported by Arduino. So if you design a custom hardware or something where you have to bring up the board, I would say like that would be a very easy way in Arduino, because you can test out all the peripherals and all the hardware part of the things easily from Arduino side of the things, because both test up, and then they could move to their own IDE where they can debug, they can write the application code like a very optimized application code. But to bring up and to design a POC to get all the peripherals running, external sensors working, they can actually use it. Actually, I would say it's like a, it has become a Python, new Python, I would say, like in the embedded space of a thing. If Python is for softwares, Arduino has become a tool for embedded, I would say, embedded. So right now there is so many companies who support, actively support Arduino. So it has gained so much momentum now. So yeah, so mainly POCs, board bring up, these kind of situation, it would be like really useful. I have used it in all two companies where I worked actively, and even like we were in my first company where we were designing a test gears basically for ISRO, and I developed on Arduino itself. So those test gears, at least the POC part of it. So we did like, even the, I think the production version would have been went out with the Arduino as well. So those test gears. So yeah, so this was not a big complex thing or anything. It was just a voltage measurement kind of a device, but very accurate voltage measurement. So I had to write. So the thing is like, even I had to write a library for a ADC actually, and at that time I was using STM controller itself. So I went to STM IDE, like STM, and at that time I don't think so the Cube IDE was that popular. Even now it's fine. That it's so cluttered. I would feel like the IDE is so much options are packed into a single screen, and it's not navigatable. That is a feeling you get from that IDE. But yeah, so and then that is what I feel like. Those Arduino, it's just three symbols you there, and you just upload, verify, that's it, done. Most of the code is done there.
So one of the things that Navadeep and I were starting to talk about in the dev chat earlier was, man, there were a lot of ST users in the recent poll that we did, right? So this is sort of a non sequitur from the fact that we've been talking about so many people getting started with Arduino and then trying to take it into production, like basically everybody said here. Why is it, Amesh? I'm going to ask you this. Why is it that STs become so popular, at least to now? And it looks like ESP may be on a similar trajectory, to where SP was for maybe this generation. Why did ST become so popular for the non-Arduino, for the professional side of the Arduino deployment?
Yeah, I think they cracked the code what Arduino has cracked in 2008 and 2009. They understood the significance of software, they price it properly, and now their software ecosystem is getting better and better every single day. Okay, I have seen STM, and STM32 from very basic libraries. Then I mean the first version was a basic library where you do a bare metal code. Then comes the standard peripheral library, std lib peripheral, and then come the hell library. So hell is not basically the final, it's just in a journey how they developed the ecosystem, but they learn why Arduino becomes successful, and now they are trying to implement everything into the hell. So the system and development become way more robust. When I understand people say that hell is painful. I know sometimes, when you auto generate code, it rewrites and syntax and everything, I understand that. But we have to understand, when we are working on commercial product, and code of that complexity, it's a painful, it's a difficult, but it still saves a lot of your pain point. So the long story short, they understood how important the software is, and now I feel they have much bigger team uh, to maintain those code and a quality documentation, which is what Srisha mentioned in very early days. That's why I said in early days, learning STM32 even wasn't that happy journey. I remember there were only one blog that was a Polish blog, not even English. It is a Polish. I used to translate, sitting in Germany, learning German, reading Polish blog, translating Google Translate, and then trying to learn out of that blog. So it was very painful. But right now, I think they learn how important it is, and uh, they are very committed to that. And talking about ESP32, I don't really feel by myself that they would catch up to where STM32 is. It's very blunt, but that's what I make my point. Because in software they have to learn a lot of things. Every time I try, every time I frustrate, I have to hire one person to just carry this pain myself, and I just give it to that ESP32 guy in my company, and then give all the shits, this changes and compiling problems and all things to him. So I don't think ST is way more better in that case.
So the upshot here, if anybody, if you're just on the chat and you're not in the screen share or audio share, feel free to post any questions or thoughts or comments here in the chat, and we'll either address them here or feed them forward back in the Discord server. So what is the best place if you are a developer then to spend your time to learn, right? Should you commit yourself to Arduino and just hope that the wave keeps growing and takes over, or do you need to be dedicating your time to ST? Where's the best place to? Time's the only thing the non-renewable resource, right?
For learners, it's always recommended to start with Arduino, okay? And never ever underestimate 80 mega 328 microcontroller. Okay, don't do this mistake in your life, because I have seen very experienced, even scientist people would go and download that GitHub library that's written for XP and very rare component on the planet, and then they read the pre-written library. It's not because they don't have intellectual capability to write their own code. The problem in life is you don't have a time to read this 800 pages data sheet, which the DGXB put up. I don't have that much time, and whoever have that time to read and understand this is an idiot, I would say straight away on a camera. So the point is, learn Arduino and learn libraries and protocols. How the technology work, that is important. Once you crack the code, how particular protocol, how particular technology is working, then your life become very easy when you migrate to the professional code, right? But if you directly jump to the professional microcontroller, I think Mike might agree with me that early days learning embedded wasn't very very short journey. It was very long journey. People used to spend 5 years, 7 years, 8 years, and then they become in a position where they can write assembly code of like 10,000, or not 10,000 is too much, but the 1,000 lines of code assembly, 1,000 lines of code is super complex, right? So, and right now you see people come like out of university and say, okay, I build Ethernet driver, I build Wi-Fi driver, and I was shocked. Oh my god, I spent 5 years for this. But they could able to do that because of this Arduino. We couldn't able to do that because in our case we didn't have the data sheet, we didn't have the library to read. So use this Arduino ecosystem and leverage on the top of that.
Awesome. Tricia, Vedant has a question for you. He says that you said that you used Arduino to build an industrial grade application in your first company. How far can you go if you launch ESP32 or Arduino based products for in the industrial sector? Can it withstand industrial factors like high vibration? I think I know the answer, but
Hello. So the thing is, the ESP32, they are the people who design the board. So if you are developing your own Wi-Fi module based on their IC, then the vibration test, I'm not sure, because how that would fare out. And the similar thing, hardware wise, I wouldn't say like if it is developed on any platform basically. So not just the software wouldn't matter at the end of the day, it's only optimization at the end of the day. So you can go back to the original people who, like for example the company, for example you could have a custom STM32 board developed, a flight controller board maybe, and then maybe test out all the features using Arduino, all the peripherals, all the sensors, and get it to the point, okay, my hardware is complete now, I can go forward with the hardware. And yeah, so and then maybe like go back to the STM32 cube IDE and generate the code there, and then start developing all the nitty gritty things, like all the situation taken care of, all the PID loops, all the flight controller stuff, algorithms developed. So I would say like to the level of board bring up, Arduino is the better place. And even to the point of POC, maybe if you have some kind of client coming in and you need it, get it done in a week, I want a demo, at least a blinking LED, something should be there on this hardware. So that kind of a thing, like if you comes, your manager comes and says to you, that's the best situation would be go to the Arduino. Anyway, you write the code, blink the LED, and say like, okay, this part is done. So let the investor clients, okay, be happy. Okay, they have some hardware developed and it is blinking LED at the end of the day. So they would know that this is fine, it's working right now. And then maybe sit down for a 6 months, get your everything. I would say standardized. Basically, the code needs a standard as well. Some of the ISO standards and those standards, medical devices have its own standards, so that should be followed. So at that time, you will have a time to develop it. But at the when you're trying to get your client happy, trying to get your investor happy, I would say blinking LED is the hardest part, even in the original, like the main manufacturers ID, you do not know what to do with the some of the IDs. So it's some of the time it's very tricky, you will have to pay a license fee. Some of the times it used to be like that, nowadays people have gone open source route. Still its navigation of STM32 could look very hard in the beginning, cube ID, because you have to actually assign the pin, then all the features you have to assign in pin IOC, and then start developing the code. So that is not the way in idea like Arduino. You just go to the website, somebody has already written something, you copy paste it, okay, done, dusted. So yeah, it has been, yeah, I would say like till the point of POC, and then hardware bring up level. So testing all the features, that is fine for the Arduino level, and then move on to the professionally. Like if you have some kind of, if it's a medical device, then you have like a standards to follow, so you'll have to follow them. So yeah, so at that time you'll have to do with the go with the manufacturer's software, or like a professional software piece of kit. Yeah.
So, Mesh, I want to get Vedan is typing again, and we'll get to that in a second. But what is the place of ESP32?
I think it's good, but I tell you, Brandon, which people doesn't talk a lot and understand when choosing microcontroller. I was working at Orbotech, right? It's a KLA company right now. It's very big corporation, and I was interfacing the memory chip from Micron MT29F at G06 at that time. I think 2011 I was writing a core. So in that case, it's a company which every application engineer, even from Micron, want to talk and sit with those R&D engineers. And I was at that position, and I got the test benches and core and everything for FPGA pre-built, ready-made, because that company is an elite group, right? So I think right now ESP32 is doing that. So if you see a lot of companies is basically who assure the volume, give them a commitment, they give them dedicated support, right? Even sometimes they hire a people and then they give very extensive support to them. So I think USP would succeed and would also capture a big market share, but I don't see that ESP would gonna acquire that market share which ST has. So because ST's offering are pretty wide, right? It's not just specific to Wi-Fi only. So the ESP's point of sale is like Wi-Fi. Okay, that's what I kind of feel by myself. I may be wrong, but when it comes to power, then healthcare and many other markets where the big money is, I think that's where the ESP would have a problem. So in a consumer side, they would be very successful. even in the future, even right now, we already see that, but not so. It will be a very significant player, but I don't see it would be like everything of embedded. No, that's not going to happen.
Awesome. Well, we just we're getting down to the short strokes here. So for those of you guys who have questions or want to follow up or just keep the conversation going, I dropped the thread for this week's office hours there in the chat. And then also below that, I just put in a link to the Arduino Pro for those of you who are interested in learning a little bit more about that and what's all going on there. We do, as always, have some questions that could use answers in the community. A little under the weather. You can find these here. We won't spend a whole lot of time going through them right now, but if you do want to help out some of your fellow community members, I'll drop this slide presentation into the same thread so you can jump in and help out. Here's a list of things that we have coming up, some more demos. Palav also has his teardown time, so check that out on Tuesdays. He'll be dropping new teardowns into that channel. Also, if you are looking for or have information about a job, there's a jobs channel, and Marcus at Mark Webb he's a recruiter and server, so he can help you out there. Just either drop your information in that channel or feel free to give him a ping. Got some other things coming up, learning hours, in-person meetups. We're still working out, so bear with us on that. Continuous improvement, getting more people in the server, that's on me, and we're getting really close to some really big things, especially around the launch of the website, and we've got a social media game plan that's launching in the next week, so to keep an eye out for us on Twitter, LinkedIn, and wherever you get your social media feeds. And last but not least, anybody have anything for the community? Anybody need anything from the community? Gives and gets. Feel free to ask them now.
Yeah, so I don't
Joseph.
actually know his name. Yeah, good day. I was actually on a vehicle when we started, so I'm actually in a noisy place, so that's why I couldn't contribute much. I can't remember his name. So he asked something that he needed a guide on electronics, how to start his electronics journey. I don't know. In the dev chat, there was a thread and all that. So I'm just saying, anyone that needs like guide on electronics, how to start your journey on electronics, they can always put something on the dev chat. So I sent the link of courses that they could take, and though it's a paid course, so I said anyone that we also need my account, because my account I have lots of course. They can send me a DM, you get, on the Discord, then I can give them, and from there I can guide them on what to do. So this is just my little contribution.
Yeah, thank you for that. Actually, that's a good point. So there is a thread, and for those of you who do not know how to access threads, if you go into, for example, the dev chat up here, you'll see this little squiggly thing. This is a thread, and in here is where, I haven't joined this yet, but Joseph is referring to, he created a thread right here with Sageboy about some resources. So either find it there, or if you come back up here into the threads tab, you should be able to navigate to it. So yeah, or just reach out to him directly. He's Joseph Agbana. So anybody, Vedant has one more thing. I'm going to see if I can get this in really quickly. Is currently developing MQTT and IoT environment using ESP32 and a Raspberry Pi for his father's company, which deals with digital flow meters. He's asking whether or not he should do Arduino or any other microcontroller to develop a product like that. Let's go around the horn really quickly. It says lightning round. So Umesh, Navadeep, Tricia, what would you suggest that he do? Arduino, another microcontroller to do an IoT-based project? for a flow meter? What would you say?
My answer is yes,
Nilesh.
go. Yeah, my answer is go because you're new, and the amount of time you would spend for other chips would not worth it. So go with Arduino.
Navdeep, what do you say?
Yeah, Arduino default, and if you have time, like 3 4 months or even 6 months, then try to fiddle around STM32 or any other. Try using HL libraries, interrupts, analog reading, stuff like that, and get a sense of debugging, hooking up oscilloscope or logic analyzer, and try it out.
Tricia, what do you say?
Yeah, I would definitely recommend to go with Arduino because MQTT and IoT, those two layers, software layers, are not easy in other platforms, I would say. So those two things, if it was just a peripheral of like a I2C device, something like that, it would be. I would have recommended STM32, but no, like MQTT and IoT is not a easy layer to integrate into some custom hardware, custom microcontroller. Yeah, definitely Arduino.
Cool. Joseph, what would you say? I'm waiting for him to throw a curveball.
Arduino for the start, then dev into STM32. I guess you should do more 30% Arduino than 70% STM32. My own opinion.
Very good. All right. Well, we hope that helps. And honestly, Vedan, just feel free to drop this stuff into the chat, right? And then if it gets involved enough, we'll move it into a thread in one of the forum channels. And everybody else too. I mean, this is what this is here for, right? We want to have these office hours so that we can have exchanges and help each other out. And between office hours, we have this Discord server where all these folks are involved. And also somebody that you should probably get in touch with, Vedan, is LMTX. Lucas Malinowski. We literally were just talking about MQTT today and how to structure your MQTT topics. So he's a great resource when you get to that level of your design. Here are a bunch of the resources that we always have. Our next meeting is not going to be on 2/9. It's actually going to be some date in March already. Good Lord. I think it's either 3/1 or 3/2. But other than that, I really appreciate all you guys' time. Sorry we went a little bit over, but if you have any questions, I'm at Techilu, at Umesh Lakonde, at Navdeep Ganesh, at Joseph Ogbonna, and at Tricia. What's your handle, Tricia, in the server? I'll find it for you. Tricia N. Very good. All right. Well, thank you guys so much for your time. Oh, it's LMTX, Vedant, in the server. Thanks so much for your time, guys, and we'll talk to you soon. Have a good week.